Hello, everybody. We are going to get started with the 5.3 notes, sum and difference of cosine. I would recommend, if you don't have it right with you right now, pause the video and take a moment to grab your unit circle. We are going to be referring to it a few times throughout these notes, so it will be handy to have it nearby. All right, so cosine of A plus B. So the first thing that you need to remember is that the cosine of two angles is not simply the cosine of those two angles added together. Like, for example, if I did cosine 30 plus cosine 60, that does not equal the cosine of 90. Because if you look at your unit circle, cosine of 30 is square root of 3 over 2, cosine of 60 is 1/2, and cosine of 90 is 0. So it is not true that if I just add the two cosine values together, I'm going to get the cosine of that angle added together. So really the major thing is if you know what the identity is, then a lot of these are just kind of using the formula, plugging things in, so to speak. So the cosine of A plus B is cosine A times cosine B minus sine A times sine B. Cosine A times cosine B minus sine A times sine B. And then the difference is the same, it's just an addition sign in the middle. So take a moment to write those down. So we are going to use our formulas here to help us find the exact value of each expression. So remember, exact value does not mean I'm just going to go to my calculator and type in cosine 15 and write down that decimal. That's not what we're doing. Exact value means that we might have square roots in our answer, and it might look kind of funky, but we're not going to have decimals in our answer. So cosine 15. 15 is not an angle measure that we have on our unit circle. However, 15 is the difference, or sum, I guess, of two angles on our unit circle. 15 is 45 minus 30. And there's multiple ways to get to 15. You could do 60 minus 45. You could do some negative angles. But to me, the easiest way to get to 15 is to do 45 minus 30. So cosine of 15 is 45 minus 30. So what I'm going to do is I'm going to find the difference of these two. So I'm going to use this formula right here. Everywhere I see an A, I'm going to put 45. Everywhere I see a B, I'm going to put 30. So we're going to have cosine 45, cosine 30, plus sine 45, sine 30. And now we can plug in the exact values of those expressions. So cosine of 45, we do know, is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. Sine 45 is square root of 2 over 2. And sine 30 is 1/2. And then we continue to simplify. This gives me the square root of 6 over 4 plus square root of 2 over 4. So then I would simplify it into one fraction like this. Whoops. There we go. Now let's just see if I do the square root of 6 plus the square root of 2 divided by 4, you can see that those two values are indeed equivalent. So this is the exact value, not the decimal approximation. All right. Cosine of 5 pi over 12. Well, we're going to do the same thing, except now we're measuring our angle in radians. So I have to find two angle measures that can either add or subtract to 5/12. Now, I'm going to have to think about it in terms of a common denominator. So this is really 2 pi over 12. 1/6 is 2/12. Pi over 4 is 3 pi over 12. Pi over 3 is 4 pi over 12. Pi over 2 is 6 pi over 12. So just based on this, I can see that we can get to 5/12 if we add these two together. Pi over 4 plus pi over 6 would give us 5 pi over 12. So this is pi over 6 plus pi over 4. And now we're going to use our sum identity. So cosine pi over 6 times cosine pi over 4 minus sine pi over 6 times sine pi over 4. And once again, we're going to get those values from the unit circle. So cosine of pi over 6 is square root of 3 over 2. Cosine pi over 4 is square root of 2 over 2. Sine of pi over 6 is 1/2. Square root of 2 over 2. We continue to simplify. And we get square root of 6 minus square root of 2 over 4. And what you'll find is a lot of these turn out looking very similar with that square root of 6 and the square root of 2 over 4. Notice the only difference here is the fact that we have a plus and a minus. So, all right, example 3. This one's a little bit different. We're not being asked to find one specific value. However, what it's asking you to do is recognize that, hey, this is actually the same as one of our identities here. It goes cosine, cosine, minus sine, sine. So which one of these is that? That's this top one here. So what that means is that this is the identity of adding two angles together. This is the cosine of A plus B. Well, A is 87 and B is 93. So this is equal to the cosine of 87 plus 93, which is 87 plus 93 is 180. And that is an angle that we do know how to find the cosine of, and it's -1. All right. Example 4. Write cosine of 180 minus theta as a trigonometric function of theta. So we are going to use our difference because we're taking the cosine of a difference to rewrite this expression. So we're using this guy right here, except everywhere I see an A, I'm going to put 180, and everywhere I see a B, I'm going to put theta. So I'm going to have cosine 180 times cosine theta plus sine 180 times sine theta. All right, cosine 180 is -1. Sine 180 is 0. So that goes away, and we're just left with negative cosine theta. All right, moving along. All right, suppose that sine A equals 3/5 and cosine B equals -12/13, and both A and B are in quadrant 2. Find cosine A plus B. All right, so to find cosine A plus B, we need cosine A, cosine B, minus sine A times sine B. So right now I do have sine A and I have cosine B, but I need to figure out what the cosine of A is and what the sine of B is. So what we're going to do is we are going to draw a triangle for each one of these because we're told that they're in quadrant 2. So quadrant 2, here's angle A. And we're told that the sine of A is 3/5, opposite over hypotenuse. Using the Pythagorean theorem, this is a Pythagorean triple. That's a 3, 4, 5 triangle, but it's going to be negative because it's a negative x direction, which means that the cosine of A is -4/5. Now we're going to do the same thing for angle B. All right, B, we know the cosine, so adjacent over hypotenuse. This is again a Pythagorean triple. This is going to be 5. And if you don't have those memorized, again, it's okay. You can always use the Pythagorean theorem to find the missing side. It's just helpful to know that 3, 4, 5 is a combination that's going to go together. Same with 5, 12, 13. That's another very common combination you'll see with right triangles. And we need the sine of B, which is going to be opposite over hypotenuse. So now we have everything we need. We have cosine A, which we found here. We have cosine B, which was given to us. Sine A was given to us, and then we found sine B right here. So we have everything we need. So cosine A plus B is going to be, all right, cosine A is -4/5 times cosine B, -12/13, minus sine A is 3/5 times sine B is 5/13. And now we simplify. That's positive 48 over 65 minus 15 over 65, which gives us 33 over 65. And that would be our final answer. All right, that is it for lesson 3. We'll see you for lesson 4.